Graph Theory Class 9 Video 1. In this video we're going to talk about more special types of graphs. In particular, this time we're going to talk about subgraphs. So let's begin with the definition. It's a really abstract definition, but the concept is quite straightforward once you see some examples. So let's just try and get through the definition and onto some examples as quick as possible. A graph G prime equals V prime E prime, so V prime is the vertices, E prime is the edges, is a subgraph of a different graph G equals VE if V prime is a subset of V and E prime is a subset of E. Okay, so very abstract, but all it's actually saying is a subgraph is any graph which lives inside a bigger graph. Okay, so if you have a graph, a subgraph of it is just some subset of the vertices and the edges, which form a graph in their own right. Okay, so it's an abstract and technical definition, but as we'll see, it's not too hard of a concept. So if I draw a graph G equals this graph right here, okay, so here's my graph. Then if I want to consider some subgraphs of this graph, the following are subgraphs of G. So really simple, I could just have this. This is a subgraph. And the way you see it's a subgraph is, well, you can imagine it living inside G, right? It's a subgraph in many different ways. This particular graph, it could be here, it could be here. There's many different ways in which this graph is a subgraph of that graph. Okay, but we only need one, so that's good enough. So that's a subgraph. I could draw a slightly more complex graph. This is a subgraph, and again, you know this because you can picture it living inside. It's right there. It's living inside the bigger graph. Okay. Maybe I can draw this. This is a subgraph as well. So again, you can picture this living inside. And it lives inside in more than one way. I could consider it there, or I can consider it here. Both is perfectly fine. Okay. So let's do another example, maybe a slightly harder example. Let's consider G equals K2, 3, which is a fancy way of saying this graph right here okay, so this is G, and I'm going to say the following are subgraphs. The following are subgraphs of G. So I could take the square graph, or if you want to give it a name, remember it's called C4. C4 is a subgraph of K23. And how do I know this? Well, ideally I can find it somewhere. So let's try and find it. I think if you take that pink graph, redraw it, it's that, and this is isomorphic to the square. Okay, so secretly this square is living inside of G. It's just a bit hard to see, but that doesn't mean it's not there. Okay, so C4, the square, is a subgraph. How about if I draw this graph here? It's just a really long path. Okay, so I think this is living inside here as well. So let me try and find it. I go down there. Oh, actually, I should have started somewhere else. So maybe I'll start here. Go to here, go to here, go to here, go to here. And if you draw what that is, it's this, which is equal to this. Okay, so that's living inside here as well. Maybe some things that are not subgraphs. So the following are not subgraphs of G. Okay, so G is the same graph. Okay, G is this K23, and I claim that this is not a subgraph of K23 because nowhere in this graph up here can you find a triangle. Okay, it's just impossible to find this graph living inside of this graph, so it's not a subgraph. Okay, similarly, this is not a subgraph of this graph. Okay, because you just can't find this living inside there. Okay, let's do one more quick example. So this time I'm going to let G equal K5. And if you remember, K5 is the complete graph on 5 vertices. So I draw 5 vertices and then I draw all the edges possible like this. This is what K5 looks like. Okay, and I say the following are subgraphs of G. Okay, so I could take the square. Okay, and there's probably lots of different ways the square is a subgraph, but we just need to find one. So for example, I could take that, and if you redraw this, you get this, which is a square. So the square is a subgraph. Maybe something a bit more confusing. Maybe I could do this graph here. I claim that this graph here is secretly a subgraph of K5. Okay, well, to do this, maybe it's useful to first redraw this as this here. So if you don't understand why these two things are equal, you should think about this and make sure that you do understand why these two things are equal, right? These two graphs, they're isomorphic. And now I'm going to try and find this graph hidden inside K5 somewhere. So I could do, that's a square, and now I just need the diagonals like that. Okay, so it's secretly hidden inside there. Yeah, so this is a subgraph of this, which means that this is a subgraph of this. Yeah, and there are lots and lots of subgraphs of K5. I mean, it's the complete graph. It has all the edges possible. So that means pretty much any graph on 5 vertices, which is not a multigraph or a loop graph, is going to be a subgraph of K5. Okay, that's the end of this example, and that's the end of this video.